Today I'm going to talk to you about some units of area and some very basic area formulae. Let's just have a look at this square that I've drawn above. Let's assume that each side is 1 centimetre in length. If I'm going to work out the area of a square, because the sides are the same, it's the length or the side length squared. So working that out, 1 times 1 tells us the area of this square is 1 centimetre squared. Now let's just talk about if we were to convert this length into millimetres. 1 centimetre is equivalent to 10 millimetres, so they're exactly the same size, I'm just changing the units. Now if we work out the area of this square, the area of this square becomes 10 times 10, which is 100 millimetres squared. Look at the conversion. These are equivalent areas, just different units. You can see this is 100 times bigger than that. It's actually 10 squared bigger, or 10 squared times bigger. So let's have a look at how we convert between the metric units. If we've got millimetres squared, centimetre squared, metres squared, and finally kilometres squared, if I'm going from millimetres to centimetres, I need to divide by 10 squared. In length, we'd normally divide by 10, but because we've moved up to a second dimension, 2 dimensions, it's 10 squared. Similarly, that's divided by 100 squared, apologies, and this one is 1000 squared times, divide. Making loads of mistakes today, apologies, divide. Alright, now let's go from kilometres to metres squared to centimetre squared, and centimetre squared to millimetre squared. We do the inverse. So that would become multiplied by 10 squared, multiplied by 100 squared, and multiplied by 1000 squared. I'm now going to show you some other formulas. I might just clear some space. Now we've already noted that the area of a square is its length squared. Similarly, if we talk about the rectangle, an area of a rectangle is its length multiplied by its width. Area equals LW. Let's talk about a triangle. Any triangle, whether it's scalene, right angle, isosceles, or equilateral, has the same formula. The key to getting the area correct is making sure that the base that you've been given has a height to the top of the triangle that is perpendicular to the base. So this is a perpendicular height. Sometimes in questions this height is outside the triangle, particularly if you've got a scalene triangle that's sort of a bit like that. Occasionally we may put the height outside, but it is still sitting at right angles to the base. So just be careful there, because don't forget red herrings are thrown in. Sometimes we give another side length. So you are looking for the one that is perpendicular. The area of a triangle is 1/2 base times the height. Occasionally it's written like this, BH divided by 2. These two are exactly the same. They've just been written where the coefficient of the BH has been pulled out the front, which is 1/2. I'm going to clear some space and have a look at some other formulas. I'm just drawing up here a parallelogram, and with parallelogram we've got a base and you also need the perpendicular height. Okay, that means it's got to sit at right angles to your base. We can also look at the rhombus as well. The rhombus is parallelogram only with all equal sides. The area of a parallelogram is its base times its perpendicular height. And that's pretty much all the formulas and the units that you need to know for area.